Let's look at the solutions of geometry bites. A rectangular ground of dimension 200 meters by 150 meters has two crossroads passing through its center. One of the roads is parallel to the length and the other is parallel to the breadth of the ground. If the width of both the roads is 5 meters, find the cost in rupees of laying bricks on the roads at the rate of rupees 2 per meter square. Okay. We have a rectangular ground, something like this. There are two roads going, something like this. So area of, if this is 5 and this entire thing is 200 and this is 5 and this entire thing is 150. For this, the one that I have shaded, can you see this rectangle is 5 into 150? Area is 5 into 150. For this one, the one that I have made one unbroken line in, the area of that rectangle is 5 into 200. The problem is within this space has been counted in both these rectangles, so it needs to be deducted. 5 into 5 dimensions of that box, and in order to calculate the total cost I need to multiply this by 2. So finally I will have 345 into 5 into 2, or the final answer would be 3450. Final answer will be 3450. Next question. A rod of diameter 12 centimeter and length 80 centimeter is melted and recast into wire of a uniform cross section. If the length of the wire is 5 meters, find the diameter in centimeter of the cross section of the wire. Pay attention, this question is simple, at the same time laying out certain traps. First is, they don't tell me the radius, they tell me the diameter. So the R here is 6 and length is 80 centimeter. We've taken a rod, we've made a wire, both of them are cylindrical in shape. So volume wise, pi R square is 36, height was 80, is equal to pi R square we need to calculate. Height is 500. Pay attention, it is not 5 meters, it is 500 centimeter. We want the units to be identical. So pi and pi gone, 80 and this gone, 4 and 25. So R square turns to 36 into 4 by 25, or R will turn to 6 into 2 by 5, which is equal to 2.4. But again, the question is not asking me for R, the question is asking me for diameter. So make sure you end up marking option A as the answer, not B. Next question. In the diagram shown below, O is the center of the circle, the radius of which is 8. If OP is 10, this length is 10. Can you see here? If I join it, this will be 8 because radius of the circle is 8. Now this is a 90-degree triangle, AOB, because PA will be tangential. PA is a tangent given. So this is 8, this is 10, this will be 6 now. Diagrammatically, it seems odd. 8 is such a small length and AP is such a huge length, but the diagram is not according to scale. They've given a diagram that they like. Okay. Finally, they've asked, and they've also told me PB is equal to 5. So this is 5. What is the length of BC? This length is BC. Okay. So according to the tangent secant property, PA square is equal to PB into PC, or 36 is equal to 5 into 5 plus x. 5 plus x is equal to 7.2. X is equal to 2.2. Option A. Next, PQR is an isosceles triangle, right angled at P. Semicircles are drawn with PQ and PR as diameters. Okay. Find the ratio of the area of the shaded region to the area of triangle PQR. Okay. This point is interesting. Let's drop a perpendicular from P to, let's call this point M. Now look at PMR. Look at triangle PMR. I've dropped a perpendicular here, PMR. This is 45. This is 45. So let's say this was 1. If this was 1, so PM and MR. PM would be equal to 1 by root 2, which would also be equal to MR. Now, because PR was the diameter, can you see PMR is basically a semicircle from which area of triangle PMR is removed. In order to get these two shaded regions, you need to have area of semicircle PMR or area of semicircle with PR as diameter. From that, you have to remove area of triangle PMR. For that semicircle, the radius is half. So area of that semicircle will be given by pi r square by 2 minus half into 1 by root 2 into 1 by root 2. Now r square will be 1 by 4. So I get pi by 8 minus 1 by 4. Right now we have area for these two ticked regions. Hopefully you can see you would have to engage in the exact same processing in order to arrive at area for these two dotted regions as well. You would have to do the exact same processing. So can I straight away go ahead and write this as 2 into this, 2 into this. So now I've got my area of the shaded region, which is pi by 4 minus half. Finally, they've asked me find the ratio of the area of the shaded region to the area of the triangle PQR. Now PR is 1. PQ will always also be 1 because this is an isosceles triangle. So the ratio would be half into 1 into 1 gone. So I can take out half common. I'll be left with pi by 2 minus 1 by 1, or I'll be left with pi minus 2 by 2. This will be the final ratio, which is given to us in option C. This will be the answer. Next question. ABCD is a rectangle with AB and BC equal to 4 units and 4 root 3 units respectively. On every side, an equilateral triangle is drawn as shown in the figure. Points GOH and also points EOF are collinear. Cool. Find the area of the shaded region in square units. First thing I want you to see is area of the shaded region that they've asked. Can you see this region and this region are roughly identical? So instead of worrying about this region, can I go ahead and say this region I have to worry about? This area I need. Additionally, this region that I have is identical to this region. So instead of worrying about this, I need area of this. Oops, I've gone too far ahead. This area I need. Now looking at EGFH, can we see it is a rhombus? EGFH, it is a rhombus because it has been created using the same principles on either side. When you're creating AFD and BEC, it has been used creating the same conditions. So we need half the area of rhombus EGFH. Within this rhombus also, wonderful thing you can see. I know AFD is an equilateral triangle, so this will be 60. So this will be 30. This will be 30. So this will be 120. And we know length of AB was 4. If length of AB is 4, do we also know that length of AG will be 4 by root 3? Because for a 30, 30, 120 triangle, length ratio of sides is 1:1 root 3. So if this is 4 root 3 and this is also, now BG will also be 4 root 3. Now, let me use a red pen. If I drop a perpendicular from here to here, can you see if this is 2, this is 4 by root 3, length here has to be 2 by root 3, 1 root 3, 2. This is a 30, 60, 90 triangle. This is 2 by root 3. Additionally, hopefully you can see the length perpendicular from H to DC will also be 2 by root 3. There is beautiful symmetry within this figure. This is 2 by root 3. This is 2 by root 3. This is done. So can we find out what is the length of this line here? Will it be 4 minus 4 by root 3, which is equal to, sorry, it was 4 root 3 minus 4 by root 3, which will be equal to 8 by root 3. Now, the fun thing that you also need to know is there is just one special type of rhombus, which is the 120/60 rhombus. Although we can independently prove it as well, there is just one special type of rhombus, 120/60 rhombus, because hopefully you can see E, G, H, and F, G, H. These are two equilateral triangles that have been joined together. These are two equilateral triangles that have been joined together, and within these triangles, within such rhombus, within such rhombi, the shorter diagonal is equal to the side of the rhombus. So now I've also got the side of the rhombus, or area of such a rhombus would be given by 2 into root 3 by 4, 2 into root 3 by 4 into a square, which will be 64 by 3. Remember, we don't need area of the entire rhombus. We only need it for the half the rhombus. We only need it for half the rhombus. So this also needs to be multiplied by half. So half gone, this gone, this becomes root 3, this gone, this gone. I'm left with 16 by root 3, which is the answer to this question. Option D will be the final answer. Hopefully you learned something about manipulation with figures. I think question 4 and 5 are fun examples of that. That will be all for this set.